Let's talk about extreme values, and I'll start by drawing just the graph of a function. We'll call that function f of x. And the first thing I'd like to draw your attention to is this point here, a. Now the function value corresponding to a, f of a, notice that's the largest function value out of any function values in the function f of x. So the way we can write that is we can say that f of a is greater than or equal to f of x for all x in the domain of f. What this means is that f of a is what is called a global or an absolute maximum of f. It's the largest function value that you're going to see. No other function value is larger than f of a. And notice the global maximum is really the output. It's not the input, it's the output f of a. Alright, well the second point I'd like to draw your attention to is this point b here. And the output corresponding to b, f of b, well it's not the largest output. F of a is the largest output. But if I were to look at a small interval close to b, what we call a neighborhood, then notice that in that neighborhood at least, f of b really is the largest value. So we could say f of b is greater than or equal to f of x for all x near b. And not everywhere, but at least in this neighborhood of b. And then what we say is that f is a local or a relative maximum of f. So we've got this global maximum and this local maximum. And notice f of a is really also a local maximum because in the neighborhood here f of a is still the largest value. And the last point on this function I want to draw your attention to is the point that you get by inputting c. Right? So if we look at f of c, well, f of c is certainly not the smallest function value. I can get smaller by looking over here or over here. But at least in a neighborhood of c, it's clear that f of c really is the smallest value. So f of c is less than or equal to f of x for all x near c. And so f of c is a local or a relative minimum of f. So we've got a global maximum, a local maximum, and a local minimum. But in this case, there is no global minimum. So f of x has no global minimum. And that's because no matter what function value I look at, right, even if I looked at function value way down here, well, I could always get smaller than that by going, for example, further in the negative x direction or further in the positive x direction. There's no single function value that's the smallest I'm ever going to find. So f of x has no global minimum. However, there are, of course, functions that do have global minima, and I'll just draw one real quick. Kind of the prototypical example is just a normal upward opening parabola, like so, and I'll call this g of x. And we can see that g of x does have a global minimum, g of d, which is a global minimum, because the output value, g of d, is smaller than every other output value. So kind of the wrap-up is there are 4 types of extreme values. All right, so we have maybe a box. Here we have global or local, and we have max or min. right? And so there are just 4 different kinds. Not all functions have all 4 kinds. Some of them don't have any. So maybe what you can think of is a function that does not have any extreme value, global, local, or otherwise. And then some functions have all 4 types of extreme values. So this is another example of a piece of structure that you look for when you're learning about different functions, is what type of functions have these extreme values, and how can I use that to my advantage.